Okay, today we are going to learn about conditional statements. And actually, conditional statements is something that can be applied to real life situations. And ironically, lawyers use this process, it's called deductive reasoning, in order to prove their points in cases. Okay, and mathematicians have used this to prove conjectures about certain assumptions. And we should become, familiar with the rules of logic throughout this course. Okay, so basically, writing a conditional statement is just taking a statement and changing it into an if-then statement. So for example, it says a 1902 advertisement claims that eating Quaker oats will keep you young. So we have to change that into a conditional statement, an if-then. So if you eat Quaker oats, then you will put off old age. Okay? Notice that there is a subject. Okay, you need to have a noun in there when you write these statements. Okay? Another example says perpendicular lines form right angles. So if lines are perpendicular, then they form right angles. Okay? The if part is known as the hypothesis, and then the then part is known as the conclusion. Okay? So first thing we're going to do is just identify the hypothesis and the conclusion, and then we're going to go ahead and write them in if-then statements. So it says a midpoint divides a segment into two congruent parts. So a midpoint is the hypothesis that a point is a midpoint. If a point is a midpoint, then the conclusion happens. So if a point is a midpoint, then the point divides the segment into two congruent parts. Okay, and I know a lot of times we want to write abbreviations, but we need to get used to writing things out and using our explanation, using our words. Okay, so we took the midpoint, which was the hypothesis that a point is a midpoint, and the conclusion is if that's the case, then the point divides the segment into two congruent parts. In the next example, oh, and I just realized I forgot to double underline our conclusion up top. Okay, so let's make sure we do that in the next example. So equal angular triangles are equilateral. So this is our hypothesis that a triangle is equal angular. The conclusion is that it is also equilateral. Okay, so I'm going to zoom in so I can write. So if a triangle is equiangular, then the triangle, and notice how I'm using the subject again, I'm not using a pronoun. Okay, I'm not saying then it. Well, what is it? Okay, then the triangle is equilateral. Okay. And then lastly, an obtuse triangle has one obtuse angle. So this is the hypothesis that a triangle is obtuse, and the conclusion is that it has one obtuse angle. So if a triangle is obtuse, then the triangle, not it, the triangle, has one obtuse angle. Okay? And you can pretty much follow this format all the time when you are doing if-then statements. Okay. All right, let's move on to the next page. Now, sometimes you can take a statement and make an if-then statement out of it, but it doesn't mean that it's true, okay? The only way a conditional statement can be false, though, is if the hypothesis is true and the conclusion is false. So let's go ahead and highlight that. Okay. So, for example, if it says two angles are congruent, then they are vertical angles. So the hypothesis has to be true. But then the conclusion is what makes it false. If it makes it false, then you need to provide a counterexample. Okay? So this right here is the counterexample. Those are not vertical angles. Think of vertical angles as the scissors. Okay? Those are not vertical angles. Therefore, it proves this conditional statement false. All right, let's practice deciding if something is false or not. And sometimes what you need to do is actually create an example to see if it's false or not. So if two numbers are odd, then their sum is odd. Well, let's take two odd numbers. Let's do 1 plus 3. That equals 4. Well, that is not odd. So this is false. And that was our counterexample. If two angles are right angles, then they are congruent. Well, right angles, no matter what, are always going to be 90 degrees. So, this is true. Okay. If A and B are supplementary angles, then they are adjacent angles. So what we have to think about is, can I find two angles that are supplementary that are not adjacent? Yes, I can. Okay. And this is kind of an elaborate diagram that you will learn much more about later on. And those little arrows mean that it's parallel. I'm going to go ahead and number 2, 3, 4, 5, these angles. Okay. So notice that angles 1 and 2 equal 180 degrees. Okay. And something that you will learn later on is that angles 2 and angle 6 are congruent. And something you're going to learn tomorrow is that you can cut that middle out and conclude that angle 1 plus angle 6 equals 180 degrees. Basically, all you used was substitution. And if you look at your diagram, angle 1 is here and angle 6 is here. Those are not adjacent. Remember that in order for them to be adjacent, they have to share a common side and a common vertex, which they do neither of in this example. So this is good old false. And the diagram I showed was the counterexample. All right, now we are going to talk about different statements that you can get from a conditional statement. Okay. And before we do that, I want to take one little extra notice about right here. Okay, the negation is that little squiggly in front of the letter, which basically means it's not happening. Okay, so for example, a conditional statement is if P then Q. So this is our P, this is our Q. Okay, the converse is flipping those two. So now this is the Q and the P is located second. Okay, now notice that the conditional statement was true in this example, okay, but doesn't always need to be true. The converse is actually false in this example. So, this can be false. And think about why. we all live in Illinois, but we don't live in Chicago. Okay. The inverse is taking the P and the Q and negating them, meaning making them not. So if you do not live in Chicago, then you do not live in Illinois. So here's our negated P and the negation of Q. Again, this can be false because it says if you do not live in Chicago. Well, we don't live in Chicago, but yet we still live in Illinois, and this statement is saying that we don't live in Illinois. The contrapositive is flipping both the hypothesis and the conclusion and taking the negation of both. So contrapositive, it's the longest word out of all of them. So think about the fact that we have to do multiple things. So we have to flip the hypothesis and the conclusion, and we have to negate them. Now the contrapositive, if the conditional is true, the contrapositive will also be true. Think about why. It says if you do not live in Illinois, then you do not live in Chicago. I mean, granted, there could be another Chicago somewhere in the world, but let's not take it that far. Okay, so if you do not live in Illinois, you do not live in Chicago. Okay, this would be a really good chart to like know the definitions of. Okay, maybe make some flashcards, make flashcards on your iPad, whatever it is. Okay. All right, next. So what we're going to do is just conclude what we just talked about. So if you have a conditional statement in if-then form, remember that conditional statements are P, then Q. How do you change the hypothesis and the conclusion to write the converse? You switch them. So Q, then P. If you have a conditional statement in an if-then form, how do you change the hypothesis and the conclusion to write the inverse? The inverse is negating, so the negation of both P and Q. So not P, then not Q. And then the contrapositive, remember that's the longest word, so we need to do the most work. We need to switch P and Q and take the negation of both P and Q. So we have to flip the order and take the negation. Okay. So essentially all we did just now was recreate in words how to make all those statements. Okay, so now we're going to practice this. So remember that a conditional statement is if P, then Q. So this is our P, this is our Q. So if P, then Q. Okay. The converse of the statement is Q, then P, flipping the order. Okay. So if two angles are supplementary, then the two angles form a linear pair. Then the next thing we have to do is decide if this statement is true or false. You have to be really, really careful on this. So if two angles form a linear pair, then they are supplementary angles, which would be true because a linear pair makes a line. A line is 180 degrees. Supplementary angles add up to 180 degrees. However, just because two angles are supplementary doesn't mean they are definitely a linear pair. Okay? Linear pair has to be adjacent, and there's nothing in here that says that the two angles are adjacent to one another. All right, the inverse of the statement is not P, then not Q. So let's write that out. If two angles do not form a linear pair, then the two angles are not supplementary. Okay, again, we need to decide, is this true or false? So if two angles do not form a linear pair, then the two angles are not supplementary. That's not true. You can have two angles that do not form a linear pair, but are still supplementary. If you go back, actually on the previous page, when we provided a counterexample, I showed you one. They were not a linear pair, but they were still supplementary. Okay. And then the last one is the contrapositive, which is flipping them and taking the negation of both. So if two angles are not supplementary, then the two angles do not form a linear pair. Okay. All right, let's think about if this is true or false. And I kind of already gave you a little bit of a heads up on this previous example. Okay, but if two angles are not supplementary, meaning they don't add up to 180 degrees, then the two angles do not form a linear pair. This is true because if two angles don't add up to 180 degrees, there's no way they can be a linear pair, because a linear pair makes a line which is 180 degrees. And like I discussed earlier, if the conditional statement is true, then the contrapositive will also always be true. Okay. All right, the next page is just more of these examples, and I think this was enough, so we will stop here and be ready to work on the homework in the class. Thanks so much again, you guys, for listening, and I'm looking forward to your questions.